Hello, how are you doing, everybody? I would like to talk to you about normal distribution today. Well, this is the last topic, the last new material, and I will still go over that in class again, but I would like you to at least be able to start your homework. So if you could please listen to the next like 5-10 minutes of this presentation, it'll help you with your homework. What is normal distribution? Basically, a lot of phenomena in real life are just have a probability distribution that could be called normal. What it looks like, it's a bell-shaped curve, and in order to find probabilities using these bell-shaped curves, you have to basically find the areas under these curves. Now, normal distribution is characterized by two parameters. One is called mu, which is going to be the mean, and sigma, Greek letter sigma, and that denotes the standard deviation. So there is not just one normal distribution, but there are actually a whole family corresponding to different mu's and different sigmas. So looking at the normal curves, this is a picture of two normal curves that have exactly the same standard deviation but different means. So you could probably guess which of the curves, blue or red, has a bigger mean. The answer would be the second, mu2 is greater than mu1. And so the second curve is obtained from the first one by just translating it or moving it along to the right. Now, these would be two curves that, two normal curves that have exactly the same mean. So as you can see, the axis of symmetry is exactly the same, but the standard deviations are different. You could probably guess which of the two curves has a higher standard deviation. Remember, standard deviation is the spread around the mean, so which curve is more spread out, red or blue? And the answer is the red curve is more spread out, so it will have a greater standard deviation. The properties of standard of normal distribution include that the curve is symmetric, its peak will be exactly where the mean is, and it's going to have an axis of symmetry at the mean. The curve will extend indefinitely in both directions but never actually touch the x-axis. And the total area under the curve is 1. So this is the most important property that we will be using when we do the calculations, is what we need to know, that the area under the curve is 1. So how do we exactly find probabilities associated with normal distribution? So the idea with this is that once you're given this curve called normal distribution, this blue curve here in the picture, in order to find probability of some sort of, say, height or weight of a person or whatever it is that's distributed normally, being on that interval, what you need to know is you need to shade the area under the curve between the given interval from A to B and find this area. Generally, finding areas is a hard topic, and it's actually a topic of calculus, but don't worry about it because we're going to have Microsoft Excel that's going to help us find the areas under the curves. Well, in this particular video, from now on, I'm going to only concentrate on standard normal distribution. What is standard normal distribution? So you need to know the definition of it. The standard normal distribution has a mean 0 and standard deviation 1. So out of all different normal distributions, standard normal is just one example, and it has mean 0 and standard deviation 1. So what Excel does, it can give you, there is a function that can give you the area to the left of the given number. So for example, I want to know what is the area to the left of z equals 125 based on the standard normal distribution. So it's z standard normal, means 0 standard deviation 1. So here's what you do in Excel. You just type norm.dist. First you type the number, the 125. Then Excel will ask you what is the mean and standard deviation, and you would have to type 0 because this is standard normal, and 1 because this is again standard normal. And the last parameter is always kept either as 1, or you can type true, whatever you want. Either way, it's going to be exactly the same. So again, so you would type norm.dist 125, then it's going to say, okay, what's your mean? You're going to say 0, 1, and is it cumulative? And the answer is yes, it's cumulative. And you're going to get 0.89, 435. Now remember that these two buttons will help you go ahead and either increase or decrease decimal. So for example, if you want 4 decimal places, that's going to be 8944. This would be the picture, so you can see the shaded area. So the shaded area under the curve corresponding to the probability of standard normal random variable being less than or equal to 125 is 8944. Now the second example, which is the second case, is finding the area to the right of a number. In order to find the area to the right of a number, you have to use the property that the total area is 1. So the first thing you do is you would find the area to the left of 125, just like we did a second ago, and then you just 1 minus it to get the complement. So you would just type 1 minus norm dist and repeat everything you've just done in the first step, and this would be the shaded area. So as you can see, the shaded area to the right of 125 is if you add it to also the area to the left, you're supposed to get 1, because again the total chance is 1. So this is how you get any problem where they're asking you to find the area to the right of a number. So and again, in Excel, all I have to do is just do equal sign 1 minus whatever I just got, and that's going to give me the area to the right, or the probability of being more than. Finally, the last case that we're going to consider is the probability between two numbers. So if I want to know the area between two numbers, what I need to do is, first, Excel gives you the area to the left of a number. So take the bigger one of the two that they give you, and that would be 0.92. Find the area to the left of it, then find the area to the left of the smaller number, the negative 102, and then subtract the 2 to find the area in between. So this would be, so again, think about that. So the total area to the left of 0.92, and you take away this little piece, you get the area in the middle. Okay, so this is what you would type in Excel. You would type norm dist 0.92011, subtract norm dist the second number. Now remember that the second number should be smaller than the first one, otherwise the answer is going to be negative, and you don't want that because that's probability. So to summarize, how do we find probabilities using standard normal distribution? So we are going to look at 3 cases. So cases when finding probabilities of standard normal distribution. Case 1. I want to know what's the probability of being less than something. In order to find that probability, you're just going to type norm dist A011. Case 2 would be, I want to know what's the probability of being more than a number. By the way, more than or equal to will have absolutely no difference. This will be exactly the same thing. So what you would type in Excel here would be 1 minus norm dist, again, A011. And finally, we will have case 3, and case 3 is finding probabilities of being between two numbers. So this is the hardest case. So what you would have to do in Excel is you would have to type norm dist, first take the larger number of the two, and again 011, so like the B, and then you would subtract norm dist of the smaller number of the two, so it would be A011, and you would be done. Well, thank you.